All right, let's do the first quiz. The first quiz, what I want to do, and I want you to do it, I will place an incomplete file out there and I want you to finish it. But let's take a look at some of this. So what I want to do is I want to somewhat, to a certain degree, prove a few things here. I want to take this equation, these two, and prove that they're equivalent by showing them in this way. So here's what we're going to do. I'm basically going to take this equation. First, I'll need to decide how far I'm going to go, from time equals 0 to how far. And let's go ahead and do this. Time. And what I'll do is t is equal to 0. I want enough gradations on here that you can see it. For example, if I did like this to like 10 times pi, and then what I did is sine wave, then I do a plot, or first y is equal to sine of time, and then if I did a plot of time versus y and publish this crazy thing, I'm going to go ahead and switch it back from a PDF to an HTML, and then I'll hit a publish. What you notice is it doesn't look very good. If you want to see the points on it, we're going to do like this and publish it again. Shows back up. Whoops. Let's do, I believe X is a proper format. So what you see is, or let's try O's. Maybe I can see them a little bit better. What you see is it isn't fine enough. In other words, there's too large of a step between any two of these circles in the time axis. So what I will do is draw this down to 0.1, publish it again, and what you see is a much smoother sine wave, although you see a bunch of circles all over it. Don't like those. Take the circles off, publish it again, and it's looking pretty smooth. I may not even like that. I might need even to go this fine. Don't be ridiculous, though, because if you make them too fine, it'll take too much computational time. So you see, here's my time. Time went from 0 to 10 pi. Arbitrary. My step size between any two delta t's is 0.01. Here's my sine wave. Now, the sine wave's not what I really wanted to do, but I do need to show that there is a significance of that center term. That's exactly what I was trying to do. All right, so this is not what I wanted to do, but let me go in and put a display. I like the display better than inline. The displays are a little bit bigger, so I'll do like that with the double. And I will go in and I'm going to do copy it from the book file that I have. I don't like this split line, so I'll take it off. I'm just going to publish it to see how it shows up. And this is the same equation that ends up in the text, where I have a sine times, or as times sine of omega t plus ac times cosine omega t. Now I don't like that because it actually doesn't imply the actual values that you need to put in there. So I'm going to solve that in a second by changing these terms. Mainly, I'm going to replace this one, and I'm going to replace this one. Publish it again, and what you end up with is the actual initial conditions. So first I'm going to solve it this way. I go back, so you're going to be producing this file and turning it in. I'll give you a skeleton to it, and you'll go on from there. I'm going to attempt at this point to put another inline text and see if it'll allow me to do that. X not let's try this. Might not. It apparently messed up here, but I did get the symbol in there. Let's try that again. So it apparently, if I put text after it, it wants it to be inline. So X naught, and I might want to use a funny symbol. Let's say I wanted to use an odd symbol. Where do I find it? Let's go and look, see if I can find out where it may be. I'll go back to searching in Google for LaTeX. I think we can go to that inline coding. You see a bunch of funny arrows here. Let's say I like that one, or say I want any particular one of these. Here's one. Maybe I want that one. So there's what that one looks like. I like that. So I'll do Control-C to copy. Come back over here, put a Control-V, publish it, and it doesn't show up correct. So as many times, let me see if there's something odd about the mix here by just trying things. It does end up in the display equation. Or let's see. Let's go back, put this in here, strip that out, try that. It ends up there. So we may try to do something interesting here. However, I quickly gave that up by trying a couple other things, and I decided that I like this better. So let's say we want the initial position to be 4. We want the initial velocity to be, just making things up here. I want the mass to be 3, and I want the spring stiffness to be 5. Publish that. Take a look at it. Oh, it looks like I should be putting those on the next. Let's try this. Putting a space between each one of those. Otherwise, it looks a little strange. Publish that. And you can see I'm basically wanting to imply this equation. So the next step is, of course, I'll just do it this way, copy and then paste it again. But this time I'm just going to take that off, this off, up. And each of these terms off. Publish that, and you get sort of a repeat, but this doesn't look the same as this, so that's okay. You might not want to have the information spewed back to you. And now what you can do is, I know this seems odd, but I'll Control-V that, and Control C it, tidy it up a little bit. Now, I don't have omega right now. But we will get there momentarily. Now, the first thing it's going to tell me if I publish this, it's going to be mad at me for something. It says undefined function or variable omega. So I got to determine what that is. So in essence, I can just sort of slip it under here. Omega equals to square root of fraction, drop the k, and drop the m. Now I'm going to try this. I think there's a mistake in that equation. Oh, well, the first mistake is that. Okay, I hope I fixed it here. Had a mess up on that. Still don't have omega defined, so I guess I need to slip in here. Omega is equal to square root, okay, divided by m. Put a bracket after it. Try to publish that. So I get this information, and essentially, of course, I get a lot of data here. I don't need all this data. What I'd really like to see is I'd like to see it plotted. So I'm going to go back and remove, or not remove, but put a bracket after this, and then I'm going to do a plot of time versus x. And I'm going to do x label time. Time. I'm going to do a y label displacement. And hit a publish there, and I end up with the time versus the displacement. And I end up with a couple of extra e's in there. So my question now is, now that I know initial position, velocity, is that the same as the other representation for the displacement here? What I mean by that is we had this representation. I'm going to go ahead and try this one next. Or better yet, let's go down to the crazy one. Okay, this is the one I grabbed. Now let's grab this one. And let's take a look at it. Now what I'm going to do is create this term and then create this term and then plot it and see if it's the same. So first I put the equation in here. It's just basically sitting right in there, right there. I'm going to actually pull parts of it out, though. And the way I'll do that is specify that, say, C1 is going to be equal to this. Copy, and then paste. So what you see is there's the C1. So you see that this is going to end up right in front of this term. Then you're going to see, skip a couple spaces, and I'll call it C2. Now I'm just making these up there. I'm not fulfilling the requirement that all the symbols are exactly like the ones that were in the text right here. I'm going to go ahead and just do a copy here. I think I'm going to be carrying too many parentheses, so it will get mad at me if I do this. Unable to interpret. I think I've got too many parentheses here. I've got a left one, and then I got two rights. So I'll let you know the difference between these. It may not be able to ascertain the difference, but it might. Okay, so here is the C2. So essentially, I'm going to find a C1 and a C2, and then I'm going to put in here a term that looks a lot like, or that actually is, this term. Instead of this, I have C sub 1, and instead of all this mess, I have a C2. Publish it. This is what you're looking at. So if you look at it, you've jotted down these equations, and so now I have these two that I can start working on, C1 and C2. All right, that's fine. So here's the way I'll do this. Move on down, and I'm just going to grab the LaTeX and convert it into a MATLAB. So just grab it, do a copy, I'll paste it. You don't want to do the slash there, but you can change this, and then change this to a divided by omega squared. And I believe if I look up here, oh, I better look on the sheet itself. I don't know where. Okay, I had the published sheet. I think I did away with it. So here, let me just comment this. It's going to be mad about this, but here, I'll publish it anyway. So really what I want to do is I want the square root of the V0 squared, which is the upper term, divided by omega squared, which is the lower term, and then the squared to basically sit over the top of the x0 squared as well. So I have to be aware that instead of closing the brackets here, I need to close the bracket here. Now I'm just going to hit publish and see what it tells me. It tells me that that number, because it took the data from back up here, tells me that that number is 4.2895. The next thing I want to do is I want to check and get C2'd. I got to be very careful here the same way. Copy. I'll go ahead and drop that down. I need to change the tangent. So here I've got to go in here because I do not remember if it's a tangent or... Okay, it is... Looks like it's just a tangent. So go ahead and make use of the left bracket. Go ahead and take that out. Whoops. Divided by V0 over on the right bracket. Let's publish that. Obviously, I have something that I have messed up. Yeah, you can't do that without a times in here. Okay, so I got a 1.2 something something. Next, I want to grab this equation and put down here, right in here. So I'll attempt to grab it. Control C, Control V. Now this one's going to run off the page, but I did that last time. Here's what I mean. C1 times sine, and then the left, and then the right. I need omega, and I need a times symbol here. So publish that. Uh-oh. Blew up on me. Let's see, what did I do wrong? Probably there needs to be a times in front of this. More than likely. Uh-oh, something else. Oh, got to close the brackets here. Or get rid of that one. That shouldn't be there. I don't know what happened. So this probably will run off the page as well. So here we're running off the page. The only thing is I have now, since I have X right here and X right here, I have clobbered these things. But I can do a hold on and see, only see if this is the case. Now, if in fact it is, I'll do a Control C and then a Control V. This time what I'm going to do is plot it in red, publish that. Oh, I should have suppressed the output there. So there it is in red. Now what I need to do is I need to check it. How are you going to check this? Well, I've got a red plot. Looks kind of like this plot. Well, one of the ways I could check it is I could, well, there are multiple ways. I could trick it, and here's how I could trick it. I would say I'm just going to shift it ever so slightly and see what it looks like. Maybe I should have shifted it a little bit more than that. So let's shift it by that amount. Okay, you start seeing a phase shift here. So this is not the correct answer, but it's me shifting the thing and see if it's plotting on the same plot. So what you see is an incorrect value. This is essentially incorrect, but what I've done is I've shifted this solution to the right or left. Actually, I think I've shifted it to the left to see the difference between the red and the blue. Are the red and the blue actually on the plot? Now, another way to do this is to not shift it and to not publish it. But instead, here, I'll basically save it. I'll go back to the editor and run it. Okay, when I run it, I get a plot. Now I can hit this, which is the plot editor. And give me a second, and what you will see, I'll move it back in here. You'll see that there actually is two plots. There's a red one and a blue one. And if you put one and put the other, they are essentially the same. So in fact, they are the same. Now if you want to see a little bit higher rendition of that, you can like put markers on it and say, okay, well here's the blue with markers, and you see that the red goes right through it. Or you could take the markers off and say I want it to be a thick line. So what you see here, so you see the blue line, very, very thick. Let's make it down a little bit. See the blue line, and it basically a real thick line running through here, but right on top of that is the red line. So there is no difference between the blue and the red. Therefore, this, go back to the publish, and this publishes out to be correct. So next we're going to do the other version to double check it, and instead of going through the painful process of this, I'm going to pause it and bring back the equations, and what we'll see is we'll see that instead of a sine right here, we're going to see a cosine. Now it might annoy you, and it just got me, that this is the sine right here is very close to that square root. If you don't like that, if that bothers you, and it might, then how do we move that over, out of the way? Let's try this. Let me find it. Okay, it shoved it over slightly. So this is a space in math mode. And you can get a little extreme here and move it way over to the right here. So You might not want it to go that far. Or you might want to, okay, I want to delineate that this is a term that is different than the sign. So I might want to put some parentheses around it. Now, here's what happens with these parentheses. What you find is these parentheses are kind of small. So you see a real small parentheses to the left of the square root and a real small one to the right. This parentheses on this side looks like it's actually attached to this. So I don't like that. So I might want to do left, oops, and then a \right. Let's try to see what happens now. What you see, or what you should see, is those parentheses now encompass what's to the right and left of them. What that means is this one was the left parenthesis, this one was the right. What LaTeX did is look what was in between the left parentheses and right. It figured out the size, and then it actually put the appropriate size parentheses there. For that matter, you may not like parentheses. You might want square brackets, for example. Do a square bracket, and there's your square brackets. So there's a wide variety of things you can do here. But let me pause it and go on and do the next case, and then we'll draw it to a close because we've already gone 20-30 minutes here. So as your final thing, your final statement here, let's do a publish on this, and we're going to find a discrepancy. And your goal is to fill in the gaps of what I give you and find and solve what the discrepancy is. So if you look at it, here's your initial time. Your time goes from 0 to 10 pi, just arbitrary. We can change that. It doesn't really matter. Let's change it back to 3 pi. That might make the plot look a little closer to us. Let's go ahead and do that. The plot is like that, so it's less compressed on the page. You get a solution here. Given initial displacement, initial velocity, a mass, and a stiffness, you get an actual displacement. These are the values. This is the MATLAB code that produces them. Here's the plot. So we're checking. So the check, this would be, say, the sine check. So let's say it's the sine check. The other one would be cosine check. So let's publish that again. Okay, so what you see, there's your sine check right here, and you have a table of contents. You can go straight to it. Have too many, not enough arrows there on the cosine or on the sine. Let's put one more to have them equal. Okay, so in the sine check, you look at it. Here's the equation. Here's C1, which is this. Here's C2, which is this term right here. You add them together. You have the values get printed out here, and you look at it. Hey, they lay right on top of each other. Everybody's happy. The red line was laid on top of the black line. No color specification gives you that, I'm sorry, the blue line here. So now we go into the cosine check. Now we have the same C1, but we have a C2, which is flipping this over. Okay, what I mean by that is tangent of x naught omega over v versus tangent of v naught over x omega. Look at that again. You flip the inverse of this, and then there's supposed to be a minus sign right here. So we go about calculating this, and then we take the tangent in here. We put the C2 in here with a minus sign, and lo and behold, we don't get the same plot. Your goal is to find out exactly why this is, what seems to be the discrepancy here, and solve it out and figure this out. So I'm going to leave that to you. I'm going to post a skeleton of this in the Google Drive under Quiz 1. And let me show you where that's at. Okay, if you just go to the website here And then, of course, when you go up, you'll see that the bar goes across. But if you go to Classes, give it a second. When you get to Classes, go to Vibrations. It'll open the Google Drive, and you'll see the quiz right in here. So the file to download would be that one. You would just download it. We'll open it. So it's sat right here. I'm guessing that this is what we're looking at. You publish it. And your file only has that information. You need to fill it out, solve the thing. When you get done, email it to me, and we will go from there.